You have driven home and not remembered the drive. Not a detail of it. Not a single turn, not a traffic light. You arrived safely, you parked correctly, you turned off the engine. And somewhere between leaving and arriving, you simply weren't there. So here's the question worth sitting with. If you weren't paying attention, who was driving? Before we answer, what do you think was actually controlling your behavior in that moment? Leave your best guess in the comments. Let's see how many people understand this before the science explains it. Most people assume the brain works like this. A situation arises, you think about it, you decide, you act. The reality is stranger than that. Right now, your brain is coordinating breathing, posture, balance, and vision simultaneously, without asking your permission. If all of it required conscious attention, you'd be unable to function at all. So the brain does something remarkable. It learns a task, then it stops thinking about it. Neuroscientists call this procedural learning, the shift from a skill needing deliberate attention to one that runs on its own. Early on, learning a new route relies heavily on the prefrontal cortex, the region behind deliberate decisions, and a metabolically expensive one to keep running. As the behavior repeats, processing shifts toward the basal ganglia, deep structures central to habit and well-learned sequences. The drive home didn't happen without a driver. It happened with a driver so well practiced that conscious oversight was no longer required. That's the first answer. It's not the real one yet. If you enjoy uncovering the hidden mechanisms behind everyday life, consider subscribing to Whydecoded. Every week, we decode another mystery your brain has been running without you. But if the brain can automate driving this completely, why doesn't it automate everything? Here's where it gets stranger. The brain doesn't just automate actions, it automates predictions. Research suggests the brain isn't passively receiving the world. It's constantly forecasting what's about to happen based on everything it has learned and correcting itself when reality doesn't match. Walk into a familiar building and your brain has already modeled the next corridor before you turn into it. Reach for a coffee cup you've reached for 1,000 times, and the movement is underway before you're aware of deciding to move at all. This framework, predictive processing, remains actively debated among researchers, but it captures something real about how the brain manages complexity. Familiarity doesn't just make things easier, it makes them invisible. Now, think about what that means for a habit. A habit isn't just a behavior that became automatic. It's a behavior that became part of the brain's model of the world. Research from Anne Grabiel's lab at MIT shows the basal ganglia compresses a long chain of individual actions into one routine, wrapped inside a single start signal and a single stop signal. Which raises an uncomfortable question. If habits become this automatic, why are the bad ones so hard to break? Because the routine isn't stored as choices you can overrule one at a time. It's stored as one chunk of neural architecture, activating whole the instant the right conditions appear. That's not a failure of willpower, that's a description of the architecture. If the brain continuously automates repeated behavior, then much of everyday life isn't being consciously directed in the moment. It's being replayed. That doesn't mean conscious thought is absent. It means it's selective, rationed for novel situations and real uncertainty, while familiar situations run on systems that already did the work. Which brings up the next question. If prediction is this efficient, why does the brain still get caught off guard? An enormous amount of incoming sensory information is filtered out before it reaches awareness at all. Background noise, the pressure of clothing on skin, all processed, none of it demanding attention. Until something changes. And here's the part that should genuinely surprise you. The moment a familiar sound turns unusual, conscious attention doesn't gradually notice it. It arrives almost instantly. A full system interrupt, faster than deliberate thought could ever trigger on its own. If automatic systems exist specifically to save energy, why keep an interrupt system running at all, constantly, in the background? for things that almost never happen. Because efficient isn't the same as unmonitored. Your awareness isn't absent during automatic behavior. It's on standby, watching for exactly the situations that need it and nothing else. Try this for a second. Before this sentence, were you aware of your tongue resting somewhere in your mouth? You weren't. It required no attention, right up until this sentence pulled it into focus. Nothing changed about your tongue. What changed is that the monitoring system decided, for a moment, that it was worth your attention. That's the same system deciding 100 times a day what deserves you and what doesn't. Because it means the version of you experiencing these words right now is only one part of what's operating inside you at any moment.
The rest is infrastructure, running behind the scenes, efficiently, without needing to announce itself. The commute you don't remember, the words typed without thinking, the path your hand takes to the same shelf every morning. None of it is absent-mindedness. All of it is a brain that already solved those problems and moved its attention somewhere more useful. To be precise about what this system is, current neuroscience does not describe it as a second mind, a hidden self, or a separate consciousness beneath awareness. It's the brain's efficiency architecture, built through learning and repetition. The exact boundary between automatic and deliberate processing is still actively studied, and it moves depending on context. A task automatic in familiar conditions can demand your full conscious effort the instant conditions change.
The system that runs without you is also the system that hands control back the moment you need it. Return for a moment to where this began. The drive home, the arrival you don't remember, the question of who was there. You weren't absent. A more efficient version of the task was carried out by systems that no longer needed your involvement, while your attention was free to be somewhere else entirely. The brain wasn't running without you. It was running so well it never needed to interrupt you. Notice it now. The automatic reach for a phone, the familiar route through a familiar place, the words leaving your mouth before you've consciously chosen them. None of it is random.
All of it is architecture, built quietly, optimized gradually, running long before you ever thought to ask who was actually in charge. Was the science what you expected? Go back and check your prediction. And here's the question worth leaving open. Now that you know this system exists, which automatic behavior in your own life has been running the longest without you noticing? Leave it below. We read every one. If you're curious about how your mind and our world really works, subscribe to Whydecoded, because everything has a reason. We just haven't decoded all of them yet.